Well, brass is a very important material that we believe enables advanced manufacturing technology. Brass is certainly known for its superior machinability, but we believe there's significant upside potential for brass by being able to run it at faster machining speeds than we know it's capable of. And we're excited about SPR because they allowed us to show a practical example of these high-speed machining capabilities in action on commercial part designs.
SPR machine is involved in aerospace and in the medical industry. We also serve many other markets as well. Yes, we had a customer come across, a friend of mine. He's involved in remote control car components and wants to upgrade parts that you buy. So we did some design work and some thinking on how we can utilize my machine shop and materials, which then brought us to brass, because brass machines a lot easier. Brass has a good look to it, and it also adds weight in features where they want low center of gravity weight on some of these components that we're making for our remote control car industry.
There's compelling evidence in both laboratory and production settings that brass can be machined at extremely high speeds with minimal tool wear, good surface finish, and excellent chip control. We're excited about the opportunities this presents for shops like SPR to be able to increase productivity and even profitability by tapping into the high-speed machining properties of brass alloys.
Initially, we were approached by the Copper Development Association to explore how machinable brass can be and identify the advantages of brass over steel and stainless steel in a lab setting. We took the data that we compiled from a series of machinability tests and optimization program that we ran, and we wanted to roll this out in a way that would connect with practical manufacturers. So in terms of production, SPR increased their throughput from just 76 parts in an 8-hour shift to 191 parts. And that was a combination of good material choice, the free machinability of brass, balancing the workload between the main spindle and the sub-spindle, and improving each individual operation, applying aggressive feed rates, higher speeds, greater depths of cut, and also being innovative using broaching tools versus live tools for producing multiple features.
You know, some of our parts are not for aesthetic use at all, and it doesn't matter about how they look, but when the customer sees it in their hand, it adds a whole different value. It's also adding a lot more strength and weight. You know, with the one components we do for the remote control car industry, they're looking for weight. So that adds the weight to their axles, also adds strength in areas where they would like to have it as well. And it's a value. You know, we don't have to coat it. With steel, we'd have to potentially coat it for rust. Whereas here, we can basically, it comes out of the machine, we blow it off, we inspect it, baggage it up, send it to the customer.
The free machinability of brass allows for you to attack the operation from all angles. You can take bigger chip loads into the part, you can cut as fast as the machine will handle, and virtually you won't see any tool wear by the end of the shift. And that's what manufacturers want to see, especially when they're running lights out production or want to have one man 10 multiple machines. Brass offers some of that free machinability.